So let's get into what a blockchain is. And this is going to be a fairly high-level description of a blockchain. Later in the course, we're going to peel the onion back and go a much deeper look at specifically different types of protocols. But one thing that's important to understand is that blockchain is not new. Well, the technology is not new. The combination of these technologies, the way it's being used is new. But a lot of this technology has been around for a long time. So when we talk about what a blockchain is a growing list of records, typically organized into something called blocks. It's linked together using cryptography. And so what that means is you can take any information and you can encrypt it, right? And then you can take that encrypted information from one block. So actually you can take all the information in a set of records, you can essentially encrypt that, put that in a block, encrypt that block, and then put a fingerprint of that block into the next block. And then encrypt all of those records, create a fingerprint of that block, put that in the next block. And so by having these fingerprints of the previous block in all of the blocks, you've linked them all together so that if anybody makes a change to any of the earlier blocks, essentially it'll ripple through all of the subsequent blocks. And we're going to explain when we talk about hashes exactly what that is and how that works. In each block, you'll see a cryptographic hash of the previous block. That's the fingerprint we were talking about. You'll see a timestamp or a date timestamp. And then you'll see what the transaction date is, whatever that information that is in that block. So blockchains are resistant to modification of the data. They tend to be open, distributed ledgers that can record transactions between parties efficiently and verifiable in a permanent way. And so, of course, the more nodes or computers you have on the blockchain, the more immutable it is. So it's typically managed by a peer-to-peer network collectively adhering to a protocol. When we talk about a protocol is a common set of language, agreements, understandings. So when we talk about the internet protocol, all the computers on the internet, they understand that to communicate with each other, they have to follow certain rules. And so you'll see something called HTTP, Hypertext Transfer Protocol, or TCP/IP are protocols or languages or a common set of rules that the computers can use to communicate to one another. So a blockchain essentially is a protocol. It's a common set of rules and understandings that the different computers will use to interact with each other. And once recorded, the data in any given block cannot be altered retroactively without alteration of all the subsequent blocks, which requires consensus of the network majority. All right, so if I want to send you a Bitcoin or a token using this particular protocol, I'll have a computer, a cell phone, I'll have a wallet on some electronic device. And let's say I want to send you 1 Bitcoin. So what I do is I broadcast that out to the network. And in this particular case, I would broadcast that out to a bunch of miners. But in a nutshell, what the miners are going to do is they're going to take all of these pending transactions that are just sort of floating out there, and they're going to assemble them into a block, and they're going to attempt to put that block together in such a way that meets a criteria. And that criteria is what you'll hear people saying that the miners are trying to solve a puzzle or complete some complex computational algorithm, right? But we're going to explain exactly what that is in a later module. But at this point, if you just see, they're going to take all these pending transactions, they're going to put them into a block, they'll put a date time stamp on it, and then they'll put a hash from the previous block, and then they'll try to solve this puzzle. And if they're successful, right, they'll raise their hand and they'll say, hey guys, and of course these are just computers talking to each other, it's not really people, but the computers will essentially notify the other computers and said, I've taken all of these transactions, I've put it into a block, I've connected it to the previous block through this thing called a hash, I've cryptographically connected it, and please validate this. And when 51% of the nodes or the miners say, yes, that's correct, then they all go check, 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 check. They'll all take that block with the transactions on it and they'll add it to their copy of the blockchain. So now everybody in the network will have the most recent copy of the blockchain with all the transactions. And if you think about a blockchain and the records and the blocks, think of it as a physical ledger book. And on a physical ledger book, you'll have a page, and each page will have transactions written on it. So think of the page as a block, and all of the transactions are the transactions in a block. And each of the pages are held together through the binding, right? And that binding is how all of the blocks are held together. A blockchain is like a ledger book where the physical pages are representative of a block, and the transactions on the physical page is an example of the transactions that would be in a block if this was a digital blockchain. A blockchain is a shared record book. It could be financial transactions. It could be a list of registries. It could be a ownership of car, land, ownership of a house. Literally any asset, any sort of information that you'd want to keep in a ledger, maintenance records, anything like that is what's in the blockchain. It's shared in that everybody has an exact copy, and it's constantly and regularly updated. So you can share all kinds of stuff on a blockchain, and it records the transactions and records within a period of time. So instead of turning the page, well, think of it as every, say, 10 minutes or some period of time, the page turns, and if there's any new transactions, it gets written into that new page or that new block. All right, and the pages are added in typically, again, there's alternative architectures, which we'll talk about later, but they're typically added in a linear chronological order. And then each node gets a full copy of the blockchain when they join the network, right? In addition to the blockchain, there's something called transaction database, which has essentially all of the, we'll call them addresses for now, and their balances going all the way back to the Genesis block. So there is a way to audit the movement of assets across the blockchain, even though you may not know specifically who the owner of those assets are. So there may be a record that 1, 2, 3, 5, 6, 2, 7, 8, 9 moved one Bitcoin or one asset to 7, 2, 5, 6, 3, 8, 7. Right? You'll know specifically. You can follow the traceability, but you might not know who the owners of those different addresses are. So people talk about it as being sort of pseudo-anonymous. It combines a lot of technology that we've had around for a long time, right? Large database technology, sort of the use of voluntary participants, peer-to-peer networking, distributed accounting ledgers, cryptography. All of these things have been around for a long time. And high-speed internet of things. These are all just sort of technology aspects that it all combines. And it's important to understand this vocabulary because you'll hear a lot of people use the term distributed ledger technology. And it's very, very important that you understand sort of the nuances, right? And so a distributed database, and again, these have been around for a long, long time, is a type of database where the data is stored across multiple different computing devices. A distributed ledger is a distributed database, but it's a particular type of distributed database users. So in a distributed ledger, typically you're going to see some kind of a consensus mechanism, right? And then a blockchain is a type of distributed ledger that is composed of a chain of cryptographically linked blocks containing batches of transactions, generally broadcast to all the data participants in the network. So a blockchain is a subset of a distributed ledger, and a distributed ledger is a subset of a distributed database. In other words, this picture here, I think, does a pretty good job. So you get distributed databases, of which distributed ledgers are a subset, and then blockchains are a subset of that. And then beyond that, you can even have something called a permissioned blockchain, right? So a public blockchain or a permissionless blockchain is going to basically allow anybody to connect, participate, download the software and become a member. A permissioned blockchain is definitely going to have some kind of administrator. It's going to define different roles, and it's only going to allow people to participate that meet the conditions or that have been allowed to participate. So there is a degree of control over that, whereas a public or permissionless blockchain, those kind of controls are sort of established by the community. All right, and then we referred to this a little while ago, but I want to, and we'll talk about it one or two more times throughout the course. When we talk about what can go onto a ledger, it can be all kinds of stuff. It can be intellectual property. It can be information about a video or audio recording or artwork. It can be a patent. It can be a book, a writing, anything like that. And all kinds of different financial instruments, stocks, bonds, currencies, tokens. Think of like tickets, like something with access or usage rights, any kind of record, certificate, ownership, education, permits. Even fractionalized ownership. So you might have a timeshare, and the timeshare could be represented by a digital asset, or fractional usage of a car, right? Or fractional ownership of a painting or a house, right? Then anything that is an asset that can be represented digitally could be what goes on the blockchain, right? And that pretty much covers this module. The next module we talk about, we'll get into the different use cases.